This tutorial will help you prepare for your quiz. Let's begin with the first question. Which of the following best defines a spontaneous process? When we mention the word spontaneous, it means that a process that can occur without any outside intervention. So, choice A reaction that occurs instantly, not necessarily. A spontaneous process could be slow, it takes a lot of time to finish, or it could be fast. So, not A. A reaction that requires continuous energy input, no, it can occur without. Yes, it is C. A reaction that occurs naturally without any outside intervention. A spontaneous process could be exothermic and it could be endothermic. So choice C is the right one. What does the spontaneity of a reaction indicate? Okay, let's read the choices. The reaction will always happen quickly, not necessarily. It could be slow, like iron rusting. The reaction is thermodynamically favorable, but not necessarily fast. Yes, a spontaneous reaction means that the reaction is thermodynamically favored. That's another expression to describe a spontaneous reaction. It doesn't require a catalyst. It might or might not need a catalyst. And it might involve an increase or decrease in entropy. So the best choice, the correct answer is B. Which of the following is an example of a thermodynamically favorable process that occur at a very slow rate? Okay, so melting of ice at room temperature, I wouldn't consider this slow. It might take minutes. So let's see another example. Conversion of, okay, this is the one. Conversion of diamond to graphite. So diamond and graphite, this is a network of carbon. These are allotropes and it takes years for diamond to convert to graphite. And this is a spontaneous process that it can happen just by itself. So this is a very slow one. Okay, now another choice, combustion of methane. This is instant. Dissolving salt in water, it might take a few minutes. So B is the correct choice. Predict the sign and relative magnitude of the entropy change associated with chemical or physical processes using representation and models. Okay, so entropy changes that results in a positive sign of delta S. All of the above. So, okay, which one will give me a positive delta S? Increasing mole, if a process goes to more mole, the entropy is positive. Increasing temperature as well. Increasing volume will increase the randomness. Solid to gas will increase the randomness. Forming more complicated, like we call it complex molecules as well. All of these are examples in which the delta S increases and it will have a positive sign. For example here, let's just apply here increasing mole. We had 1 and it turned 2. That's the first choice. Any reaction where temperature increases, the particles will move faster, increasing the kinetic energy. So this increases randomness. Increasing volume, so if I have a small volume and then I move to a larger volume, the particles will have more space to be distributed in, so this increases randomness. Solid to liquid to gas. As you can see over here, the particles are free to move. They are more disordered and more randomness in the motion, forming more complicated molecules or more moles. This is 2 going into 3. Breaking down of a compound increases entropy. How does a catalyst affect the spontaneity of a reaction? It has no effect on the spontaneity of a reaction. The catalyst only speeds up the reaction. So if a reaction is slow, it makes it faster. So that is choice A. Which of the following is not a driving force behind a spontaneous reaction? So delta G equal delta H minus T delta S. So enthalpy affects the spontaneity of a reaction. Also entropy. The sign of these two will determine if delta G is going to be spontaneous, negative, or non-spontaneous. So the free energy is the spontaneity of a reaction. So all of the following are affecting or the driving force of a spontaneous reaction, except that the activation energy. Increase in the activation energy means if we stop using a catalyst, a reaction will slow down. Which of these conditions result in entropy being positive? Increases. So freezing of water, meaning going from liquid to solid, its decrease, delta S will be negative. Compression of a gas. So imagine if you have a gas in a container like this, the gas has more space to move. Now, if I make the container smaller, now I'm compressing it. The gas has less space to move and it's more ordered. So this results in a decrease of entropy and it is negative. Evaporation of alcohol. So any alcohol going from liquid to gas. So that's an increase in entropy. It would be positive. Crystal from a solution. It means when we dry if I have a solution of salt dissolved in water, if it is drying the solution will result in the formation or will show the crystals. So which will become again ordered. So that's a decrease and it's negative. So the correct answer is C. Okay. Define a spontaneous process and explain how thermodynamics is involved. A spontaneous process will occur spontaneously without any outside intervention. Or any energy input. It doesn't require energy input. Now, thermodynamics will tell you whether a reaction is going to be spontaneous or not, depending on this relationship. Okay, so it will study the changes between enthalpy and entropy in order to decide if a reaction is spontaneous or not. Now the next question, why spontaneity of a reaction does not indicate its speed? Because it only indicates if a reaction is favored or not. That's the sign of delta G. That's it. It's not related to kinetics or activation energy. Because activation energy will determine if a reaction is slow or fast. Provide an example of a spontaneous process that occurs slowly. For example, as mentioned in the previous Choice: diamond changing to graphite. This is spontaneous, but it takes a lot of time, years. Another thing, rusting iron, for example, might take months or years to rust. Explain why non-spontaneous processes are not impossible. Well, if we provide the a non-spontaneous process, it needs intervention. So if this intervention is provided, then the reaction can occur. So here we would say non-spontaneous process can occur if it is driven by external energy input, or if it is coupled with a spontaneous process that will give it the necessary energy. Like, for example, this is something that we are going to study it in our next lesson. Electrolysis or an electrochemical cell. We use electric current to initiate the decomposition of water. So we need an electric current to initiate the decomposition of liquid water into hydrogen gas and oxygen gas. So without this energy, the reaction will not start. It will stay non-spontaneous until we provide this option. Now, moving on, these questions, you can read them in the notes that I sent you. Now, identify 4 processes where entropy will always increase. Immediately think about the phase changes. So, solid to liquid. So you could say melting of ice, melting of a metal, melting of sodium chloride, any melting process. Also, liquid going to gas, any evaporation process, evaporation of water, evaporation of alcohol, evaporation of benzene, ethanol, anything. Mixing, dissolving, mixing of gases, dissolution of solid solute in water. So from solid to aqueous, you can say dissolving salt in water. You can even name the salt. And the aqueous solution, a dissolved gas escaping the solution. Okay. For example, I can also give another example. Dropping an ink in a solution, so the ink will spread. Now again, the driving forces behind a spontaneous reaction, delta H and delta T. So a spontaneous reaction is driven by enthalpy and entropy. Now, if a reaction is exothermic with an increasing entropy, this reaction is always spontaneous. Explain why entropy increases as temperature increases and provide a real-world example. As temperature increases, particles will gain kinetic energy and move more randomly, increasing the disorder. For example, heating a gas causes molecules to move faster and spread out, and this will increase entropy. You have this answer written in the answer key that I sent you already. The second law of thermodynamics states that the entropy is always of the universe is always increasing. So the entropy of universe is in continuous increases. So for a non-spontaneous process, we need to provide energy so that the reaction will start, and to keep the entropy of the universe in continuous increase. Now moving on. Okay, the first law of thermodynamics, it's the law of conservation of energy. Energy is not created, not destroyed, it just changes from one form to another. You should not say the law of conservation of matter. This is a misconception. It's the law of conservation of energy. State the first law of thermodynamics. I just mentioned it. So energy cannot be created or destroyed. It can only change from one form to another. Moving on. Okay. So the second law of thermodynamics, the entropy of the universe is in continuous increase. So this is the first law. This is part of the law. This is wrong because spontaneous process doesn't require external energy. Okay. So explain the concept of the second law of thermodynamics. Since we're saying that the entropy of the universe is increasing, just keep in mind that any process, when it happens, this is more randomness to the universe, more disorder to the energy distributed in the universe. In an exothermic process is a process that releases energy. The system will release energy to the surroundings. Therefore, if I look at the surroundings, the entropy of the surrounding increased because the surrounding just gained energy. Okay, why does the entropy of the surroundings increase in an exothermic reaction? I can prove this in the entropy of surrounding, which is a formula that you can memorize, is the enthalpy of a system of a reaction divided by temperature. So if we are dealing with an exothermic process, so there's a minus in the formula. An exothermic process also will have a negative value and the temperature is always positive. So the answer will be positive, and positive means that the change is positive, means entropy increases for every exothermic process. In an endothermic process, the system absorbs energy from the surrounding. So in this case, surrounding is losing energy, so the entropy of the surrounding decreases. Again, I can prove this with the formula, explain why the entropy of the surrounding. So if I think about this is the entropy of the system divided by temperature. So there's a negative in the formula. And for an endothermic process, the enthalpy is always positive and the temperature is positive. So the answer of, or the value of the entropy of the surrounding will be negative. Negative value means that it is decreasing. Okay, now next. Entropy is temperature dependent. Of course, if you look at the table of molar entropies, entropy of a substance will change from a temperature to another. So if temperature increase, there will be more motion of the particles. So the particles will move more, faster. Also, their rotation will be more. This affects entropy directly and it will increase. So this is wrong. entropy only increases with temperature. No, not only. So there are other factors that can increase entropy, like molecule complexity, dissolving it. So this is a very confusing answer. This one, see, heat transfer has, okay, so heat transfer has a great effect at lower temperatures. Yes, you know, the heat, whether the temperature increased or decreased, this will affect the entropy. So I would take choice B. So if I gave lower temperatures heat, definitely entropy is going to change. Okay, so why entropy temperature dependent? Well, at lower temperatures, the effect of heat transfer on entropy is more significant because the energy change represents a larger fraction of the total thermal energy. So if you look in that table, I think on page 21 or 20 from your notes, you will notice that the entropy increases a lot if the temperature was low and increasing, while at higher temperatures the change is not that significant, but there is a change. Gibbs free energy, that is a G. So Gibbs free energy is defined as, when we do this equation, if there is a sign negative, it means that this is the work remaining to start a reaction, the available work to start the reaction. So it's not the heat, because heat is the enthalpy, it's not the entropy, so it's the energy available to start the reaction, to do work in a system which is a reaction. And that's why we use the word spontaneous. Explain the concept of Gibbs free energy using the swing curve. This swing curve will only show you the places of delta G where it becomes more and more spontaneous. So the more it is negative, the more it is spontaneous. Okay, so I will be explaining again the signs of delta H and delta S to see when the process is depending on temperature, to see how the Gibbs free energy changes. So only in the processes where delta H and delta S, they have same sign, like both positive or both negative. Here, the more the temperature is low, the lower the temperature. So as temperature decreases, the reaction becomes more and more spontaneous. And if both of them were positive, the higher the temperature, if the temperature increase, the reaction becomes more and more spontaneous. The more we increase T, the more the reaction become spontaneous. So, as mentioned, delta G negative indicates that a process is spontaneous. So this is just the energy available, the free energy available to start a reaction. Delta G relates to the reaction speed. No, not at all. It's irrelevant of the speed. So it indicates spontaneity, not speed. Now, this formula is, I think it's given in your formula sheet. The delta G equal minus RT ln K. Here they want the relationship between delta G and K equilibrium. In your formula sheet, you have this formula and you have this formula written. So just be careful to look at the correct one. This is the correct answer. There's a negative in the formula. Okay, so explain delta G when delta H is negative and delta S is positive. As I mentioned in class, whenever I have an exothermic process and increasing entropy, this process is forever favorable at all temperatures. So if you look at the formula, delta H is a negative value, then there's a minus in the formula as you see over here. And then temperature is always positive, and we are saying that delta S is positive. So when we multiply a negative by positive values, we will get a negative value. So negative value plus another negative value, the answer will always be in the negative. So this is forever spontaneous. Next, the standard state of a gas. So the standard conditions of a gas. So at 1 atmosphere, be careful for the temperature. This is for solids and liquids. This is the condition for solids and liquids. This is the condition for solutions, the standard conditions for solutions. And this one, C, you saw it in the lesson of gases. This is the standard conditions for ideal gases. So it's not related to our lesson. Okay, so be careful to this trick. Third law of thermodynamics, as I mentioned to you, S is never, the molar entropy is never zero. The standard molar entropy is never zero except for a perfect crystal, which is present in a theoretical, hypothetical world. Okay, so a perfect crystal, entropy, absolute zero. Okay, now the standard entropy of a reaction is calculated as this formula. You don't have to worry about it because it is given in your formula sheet. Choice B is called the standard enthalpy of a reaction, and choice C is the standard Gibbs free energy of a reaction. But anyway, they are writing it wrong. Here it should be H and G. And it's delta G related to negative RT ln K equilibrium. So the right answer is A. Why it is important to know the state of each substance when calculating the standard entropy of a system, because we want to do the calculations right, because the entropy value might differ. So the entropy of H2O liquid is not the same as the entropy of H2O gas or solid. So as you know, the entropy increases from solid to liquid to gas. So you have to always pick up the correct entropy with the corresponding state. So this means that the state determines the entropy value, since gas, liquid, and solids have different entropies. Yes, it has nothing to do with the mass or the balancing reactions. Next question. Again, we need to consider also allotropes. For example, the entropy of C diamond is different than the entropy of carbon graphite, for example. So the arrangement is different. So entropy will be different. Now, let's do a question. Calculate the entropy of the following reaction. So these values will be provided. So the entropy of H2O, these are given. You don't have to memorize it. It's 69.9 a joule per Kelvin mole because it's a standard. The entropy of oxygen gas is 205.2 joule per Kelvin mole, and the entropy of H2O of H2 gas is 130.7 joule per Kelvin mole. So you always have to be careful in this formula. It's the product's entropy minus the reactant's entropy. So the entropy of products is equal to 69.9 multiplied by the stoichiometric coefficient. And the entropy of reactants, the summation of reactants, is the one of hydrogen gas multiplied by 2. So it's 130.7 times 2 plus the one of oxygen, which is 205.2. Now, delta S standard of the reaction is this value minus this value. Okay, so 69.2 minus so the final answer is negative 326.8 joule per Kelvin mole. Oh no, 1 second. Here the mole will go because it's not anymore per 1 mole. Here we don't have 1 mole, so you're just removing the per mole, so it's only joule per Kelvin. Next, the enthalpy of vaporization. Vaporization is when a substance goes from liquid to gas. Okay. Fusion, so this is vaporization. Fusion is when solid goes to liquid. Okay, so the vaporization is higher because the temperature is higher. If you notice, the diagram, the phase diagram of water is always like this. It requires this much of energy to change the process from solid to liquid, but this is always larger, because to go from liquid to gas, we need a complete breakage of intermolecular forces. So this requires much amount of energy. Therefore, the enthalpy of vaporization is higher than that of fusion. Next, use the table below to answer the questions that follow. As mentioned earlier, look at the values of the entropy if for several allotropes, and look at the molecule complexity. So C2H2, it's 200, whereas if it is 4 hydrogens, 219, 6 hydrogens, 229. So always the entropy increases with molecule complexity. Now, let's move to the next question. The value of the entropy of catalytic hydrogenation of acetylene to ethene given in this equation is, so delta S, we are going to apply the formula of products entropy minus reactants, the sum of the reactants entropy. So let's begin by picking up from the table the entropy of C2H4. So C2H4 219.4 minus hydrogen gas 100, see I'm taking the S, 130.58, and the one of ethine 200.8. So plugging this into your calculator, the answer would be choice D. The value of delta G for the decomposition of gaseous sulfur dioxide. Okay, again, okay, this time we need delta G. It's the same exact formula, but instead of using S values, you are going to use a G values. Now, note here that if a substance is in the standard form, the G standard will be 0. So let's look at oxygen. Here O2 is 0. Anyway, they are giving it to you in the table. But if it's not given, you should know that this is 0. So it is equal to products minus the one of reactants. So it is 0. You do have to mention it. Now sulfur rhombic. Oh, I don't have it in this table. But S, this is the standard form of S. Let me I'll check it. I'll check the value. So just a pause. So since I don't have it in this table, so this is a standard form minus the SO2. I just have to look at SO2 to give you the value. Don't worry, these values are given. So for SO2 gas, it is negative 300.4 kilojoule per mole. So it's this one. Oh, wait, sorry. Minus and minus. So the delta G will be positive. So the answer is D. For a given reaction with delta H minus 28 and delta G is 0 at 372 Kelvin, what is the value of delta S? Okay, so let's apply the formula. Delta G equal delta H minus T delta S. So delta G is 0. Delta H is given in kilojoule per mole. Temperature is given 372. And we need to find delta S. So delta S equal positive 28.1 divided by 372, negative 372. You will get an answer, but the answer obtained will be in kilojoule per Kelvin. So whatever, let me just get it on the calculator. So 28.1 divided by 372. The answer is negative 0.0755. The answer here is kilojoule per Kelvin mole. However, as I mentioned to you in class, when we want to use delta S, we always divide this value by 1000. So this was here divided by 1000. Since they want it in joule per Kelvin, then we need to multiply again by 1000 to return it back, convert it back to joule, and that is negative 75. So the answer is A. And that's it. The next part is not included, although we did some practice questions. I am giving this formula in the quiz with some calculations on it. So just let me just do this one because I am giving this in the quiz. So if they gave you values for delta H and delta S, please remember that this needs to be divided by 1000. Temperature, if not Kelvin, you always add 273 to make it Kelvin. So the delta G of the reaction is delta H minus the temperature multiplied by the entropy divided by 1000. So here the answer would be negative 532.2. Now, since the unit is in mole, so you will put kilojoule per mole. Good luck in your quiz. Thank you for listening.